Hopefully I'm going to talk to you a little bit more today about some of the work I've been doing and some of the learnings and insights that I've got from trying to take AI as a hammer and apply it to different problems as a nail. I just want to caveat some of that by saying that these are my learnings. This is not the gospel, and I certainly am looking forward to hearing other people's experiences and sort of pros and cons of using AI. So please do come talk to me after this talk. So yeah, I'm a product manager working at Deepmind. I've been at Deepmind for about 7 years. Before Deepmind, I was at the Royal Observatory doing a PhD in computational astrophysics, trying to run simulations of the early universe. And it was there that I sort of realized that it was a really interesting problem, but an interesting problem for a small number of people. And I was really looking for working on problems that had a much larger impact. And so I went and joined Deepmind in 2012 as a sort of general role of how do we look for problems which the particular type of deep learning that was being done at Deepmind would be beneficial for. This led us to starting working on a fashion app, obviously. That's the standard next stage. And what we were doing is using convolutional neural networks to do different types of image search and computer vision. And it was this role that really gave me my first insight into the sort of product manager-related role of talking to fashion experts, talking to a research team, talking to an engineering team, and talking to a design and product team. And how do you bring them all together to create some coherent product that can be used by an end user? We were then acquired by Google and became Google Deepmind. And I ended up being fortunate enough to work on a range of different products, including YouTube and Google Play and the self-driving cars, and also Verily's wearable for doing some activity recognition. Deepmind started up a health effort, and I just sort of jumped on that opportunity to have a really broad impact on a really important area in healthcare, including initiating the application streams. But for the last sort of 3.5 years, I've been the lead for the product health research team. This is a team that's looking to apply AI to different types of health problems. And we've been doing collaborations with Moorfields Eye Hospital, with University College London Hospital, with the Veterans Affairs in the US, and also a large consortium, including Cancer Research UK, for mammography. And I'll talk a little bit more about the Moorfields collaboration later. But I felt that no presentation in a product manager conference was complete without putting on these three circles. And so in case you're wondering, product management is here in the middle. But in terms of what does it mean to be a product manager in research, and in particular in AI research, is you essentially have no product to interact with a user. And so you are missing this user experience aspect. It creates a whole new challenge, a whole new set of interesting aspects. And what I really wanted to sort of use this opportunity to talk to you about is this, what I think is a growing trend and a growing need for research product managers that have the knowledge in AI. And I think this has some subtleties, but some similarities to product management in general, and I want to talk to you about a few of them today. So the great news is that there are many types of product management, and we've seen a number of them today. And all of them have different focuses. But there's really only one main goal of product management of what you bring to the organization, and that is a focus on impact. You're not just doing it because it's interesting. You're not just doing it because it brings revenue or it pleases users. You're really there because you're focusing the minds of everyone else in the organization to create something that's going to be impactful within that time frame. And that's what's churning in your back of your mind at every meeting is like, is this going to be impactful? Is this the right thing for us to do? And so all types of product management have that aspect. And so, even if you're, a product manager at a large organization with lots of constraints where you just need to drive the thing forward, you're still thinking about impact. Whether you're a product manager at a large organization that's facilitated into lots of different roles, and whether you're a product manager on the sort of lead ship or even on the right at the back, you're still driving impact in your organization. I'd argue that this is probably a false representation of companies, and actually your companies tend to look more like this, in which case your role is to sort of try and bring coordination. It's to pull people together. It's to be that glue between the different areas, and that glue is focused on impact. In a startup world, your sort of product management is, build the parachute while you're falling, or in this case, build the boat while you're swimming. But I wanted to sort of mention more about what I feel like product management in research is like. And this image is not to show that it's calm and collect and it's fine and you don't need to worry about it because you're not working on a real product. There's lots of people frantically doing things on that boat that you just can't see. But it's more about the space of opportunity. So the opportunity for applications of AI is enormous. And the challenge you have as a research product manager is how do you select the greatest opportunities for you to apply that hammer to. So sort of the summary conclusions of those sections are, you really need to make sure, if you're looking at impact, that you're defining a mission. But as most product managers are already aware, it's always about finding that balance, that trade-off. So you are defining your long-term mission, but you, in research, need to leave your tactics open because you have no idea what's going to work and what isn't. You need to define the type of impact you're really looking for. Is it user satisfaction, or is it lives saved, or is it reduced costs? But be flexible on your use case, because again, you really don't know where the AI is going to be best applied. Finally, as everyone knows, that lots of engineers, researchers have lots and lots of good ideas and interesting things they want to focus on, but those are not always the most impactful aspects. And so it's really important that you develop milestones, you review those milestones with people, and you're ready to pivot towards where you think the biggest impact is going to have. And finally, in research more than most, I would argue that you need to really understand your risk profile. At the very early stages, you have no idea what's going to work. As my researchers team keep telling me, we have no idea whether this research is going to work. You can't just assume it's going to work. And so you need to sort of look at how you then work towards reducing that uncertainty. So when you're thinking about research product management, it's quite challenging as a product manager because you have no product. And so you're often in this sort of tension place where you're trying to have an influence on the direction of travel, but you have nothing to ground it on. And so traditional product managers who come from a background of managing lots of different products at Google might find this challenging because they're used to having ownership of this product. But the key in Deepmind, and the key for what I would argue for research, and in particular AI, is that you need to manage the problem, not the product. So you need to remove your ownership desire of a product and instead move it to the problem, and how can you work to the best solution for that problem. And as I've sort of mentioned, I think one of the key aspects a product manager can do there is manage this opportunity cost. So AI is regularly talked about as the most impactful technology of the future. It's going to solve all of our problems. And the key issue is, it can work on a huge number of areas. So which is the right one to work on now? Which is the most impactful for the next 12 months? What is the skill set in your team and the USP that's available to you? Like, what is the opportunity cost of choosing this problem? In 12 months' time, when somebody else has solved a problem that you thought about, are you going to be really upset that you didn't pick that problem to solve? And the key is make sure that you're thinking about the opportunity cost and ensure that you pick the one that is best suited for your team and your needs and your organization. Secondly, it's despite the fact that you have no product and no user experience to optimize for, you must pull the user into your research. And so in this case, this is Elaine Manor. She's a patient with age-related macular degeneration, and she's our patient engagement lead for our project with Moorfields Eye Hospital. And so she has come in during our research process to allow our team to understand what does it mean to have age-related macular degeneration? What does she wish happened in her process of finding out her diagnosis? Where could AI help in her pathway of understanding her disease? And so I would argue that exactly the same in all sort of product exercises. In research, the user is still critically important to bring in, and no more so than in healthcare. And finally, the common design phrase is equally important in research. Now, the problem here is that we sort of have the solution. It's AI. But AI, as we were told in the previous presentation, there's a really broad array of different types of AI. And you can't get just stuck on, oh, I want to use the latest version. I want to use the paper that just came out 3 weeks ago. What you need to do is find the right algorithms that solve the problems that matter the most to you. And that means falling in love with the problem, focusing on being a problem manager, and not instead just looking to use the coolest and newest AI. And so in summary of this section, I would sort of say, when you're focusing on the impact, think about the impact of the problem, not on a product that you might be building. You don't know what that product is going to be because you're working on a very early research stage. So instead, you should think about what is the impact of the problem and how could the research that we do create the most amount of impact for that specific problem. Really think about the opportunity cost. I mean, one of the easiest decisions that I ever made was jumping onto the opportunity to work on health-related AI research. The opportunity cost there was, I could work on a range more different products, but to have the impact of showcasing and working towards how should AI be applied in healthcare was a real opportunity that I was never going to regret. But then deciding, which of these projects do we invest this, small team of 10 people on out of the whole of healthcare is a really challenging problem to really pull your head around. And if you work on one problem, say age-related macular degeneration in the eyes, what does that mean for the fact that you're not working on mammography or cancer or some other really critical problem? Does that mean that in the time that you're not producing a product to help that area, that additional people are going to undergo undue stress? And reminder of this, pull your user into your research. Really think about what is the potential application of this research and start having that conversation with the users. Nobody understands the problem as well as the user. And just to double down on this really critical final point, as product managers, we are generally used to owning the product and being the ones responsible for the delivery of that product. But in research, you have no product, and so you must instead own the problem. Now, one of the other really critical points, and this is particularly key in using AI and machine learning and deep learning, as Amar was alluding to, is you need to ensure that you're getting the science right. And in those sort of terms, you need to be thinking, how is this algorithm going to be used? And is it being used for the right use case and for what it was designed for? And there are a number of problems to overcome there, and there are a lot of people thinking and working on AI safety and ethics and regulation and legal aspects. But the most fundamental thing you can do is to get the science right in the first place. And so that means thinking about fairness in your algorithm. If you're training on a data set that comes from a UK-based hospital, understand the fact that that algorithm may not generalize well to a demographic in other locations. Be honest and upfront about that and think about ways to mitigate that when you're thinking about globalization. Like, how do you get access to more general data sets that you can test and train your algorithm on? And you need to be ensuring that you're thinking through this generalizability problem and this fairness problem and these ethical challenges in the design of your system. But also when you're talking about it and when you're showcasing it to the world, you need to be clear about the limitations and also the potential things that you might want to do to reduce those limitations in the future. One of those key aspects is how do you evaluate your algorithm? One of the ways of very quickly getting great results that you can publish is to set up a problem in a way that's really well suited to the algorithm you're using. So, for example, you could compare somebody with cancer with a very specific type of cancer to a group of people with no cancer? Can you detect cancer versus no cancer? And the answer is, like, in most cases, a deep learning algorithm would be able to do that very well. But can you detect lots of different types of cancer at varying different stages of varying different severities, which is what you see in real life, against somebody that's normal? That's what you really need an algorithm to do if you're thinking about how that algorithm is going to have practical implications. What that means is that when you are doing your testing of your evaluation, ensure that you're using a representative test set to what your real-world use case is, i.e. compare apples to apples and not apples to oranges. And finally, you need to also be thinking about the longer-term implications. So in most sort of product development aspects, you're getting quite rapid feedback. You can make a change and do an A/B test on a website, and within a few days, you'll probably know which of those two is the better option. But when you're in research and you're thinking through, well, where would this be used in a product and what impact could that have as a product, it's very hard to get that fast feedback. And so you really need to be designing into your system, like, okay, where is this going to be used? What are the limitations? What are the associations? And what's the use case that you really focused on, so that, you know, when it is used in healthcare, so healthcare is a great example here. You know, once you've done the research, you then need to prove it in prospective trial. You then need to get FDA approval, and then it's only used in product. So you need to be ensuring that you're thinking through that really long-term aspect, because you're not going to get that immediate feedback. And in the end, as a product manager, you're going to be measured by success by that application of the research, not just by getting a good paper out. So getting the science right is absolutely critical. You know, fairness is critical. You need to really be thinking about how you are training these deep learning algorithms, what data set you're using, and ensuring that that data set is representative of the test case, of the use case that you want to use. You need to be comparing against the real task, not a cleaned example that looks good in a publication. And you need to remember that your impact, which is what you're going to be measured on, is a long-term reward, not a short-term gain. And so I really want to ground some of that with an example in ophthalmology, which is our research collaboration with Moorfields Eye Hospital. So I was very fortunate when we began Deepmind Health 3 years ago to start talking to Moorfields, and in particular to Dr. Piers Keane, who was extremely excited about the opportunity to apply deep learning to 3D scans of the eye and see whether that could help with age-related macular degeneration. Now, Moorfields Eye Hospital is one of the largest eye hospitals in Europe, if not the world, and it's one of the leading research centers as well. And Professor Serpen Kaur is, you know, heading up the research group there. And so we were able to set up a collaboration. And the problem we were focused on, noting that we're focused on problems rather than on products, was that there is an increased prevalence of eye disease, and that could lead to a 3-fold increase in blindness by 2050. So this is a really tough problem that is increasing in the world as people live longer, as people get older, as there's more sort of diabetic patients in the world. All of these confounding factors leads to an increase, a 3-fold increase in blindness by 2050. And the caveats are 80% of all of this problem could be avoided or prevented or cured if it's caught early enough. And so the opportunity here for AI is, can you capture patients that are deteriorating early enough in lots of different ways to prevent or potentially cure patients that are beginning to suffer from a lot more sight loss than they previously had done? Now, the way we did that is by looking at what's called an OCT scan, or an optical coherence tomography scan. And this is essentially a 3D scan of your eye. It's like ultrasound, but it uses light, and it builds this really nice 3D scan image of the eye, of the back of the macula. It's very high resolution. The difficulty is that humans are inherently bad at looking at 3D data and really fully understanding it. There's a lot of information in it. There's a lot of subtleties as to whether this area is, is it an imaging issue or is it actually something that is, biologically relevant in the patient? And what we wanted to do was look at the problem of, can AI, and in particular deep learning, find a solution that helps age-related macular degeneration by looking at these 3D scans? Now note that at the very beginning of this project, we were not looking for the specific use case. We were saying there is a problem area, there is a data set, and there is a potential hammer in deep learning to be able to work on this. But we hadn't yet defined what the particular use case was. As we went through the project and we started developing out the systems, the example here actually shows the segmentation that the deep learning does. So we developed a two-stage network. It segments the scan and then provides a diagnosis based on that segmentation. And the segmentation uses a deep learning convolutional neural network. And then the classification of the diagnosis uses a second convolutional neural network on that segmentation. And what you're seeing here is that the green and the yellow is all sort of normal anatomical structure, but this red thing that keeps flashing up, that's fluid in the eye. And this is a real indicator that somebody either has or is going to have age-related macular degeneration. And so as we were working through that understanding, and we were able to realize that we could segment the eye and that could lead to some classifications, we started wondering, okay, is it useful to provide a simple diagnostic of has this patient got AMD or not? And the answer was no. When an ophthalmologist, an expert ophthalmologist with 20 years experience is looking at the OCT scan, they're not trying to say, does this patient have disease X or is normal? What they're trying to say is, what's the action that I need to take to this patient? What is the choice I need to make? Also, the patient usually doesn't just have AMD or nothing. They usually have age-related macular degeneration and some diabetic retinopathy and sort of several other complicating factors. And so what you really want to do, and what we looked at, was defining down, I've lost the screen now, but they were really looking at what is the action that needs to be taken for this patient. And so we looked at the use case of referral suggestion of patients. And the options really were they either needed to be urgently referred, or they needed to be semi-urgently referred, or they needed to be observational, or they needed to be routine. And so instead of just designing an algorithm that gave a warning of saying this patient has 70% likelihood of having age-related macular degeneration, we instead trained an algorithm that could provide that output, but also made an action recommendation to the user. And that was us narrowing down on a specific use case. So I've lost both screens now, so I'm going to go by memory. One of the things we really wanted to do was evaluate this on the appropriate problem. And so we went back to Moorfields and asked them specifically for a specific type of test data set that would be as representative to the problem as we could get. And by that we meant we got them to look at patients that had just had an OCT scan on their first referral, and then look at all the future data for the next 1-2 years, and then instead of using what a clinician provided as the recommendation on that day, we used what a clinician reviewing all of that 2 years of additional information would have said had they had that 2 years information on that day. That gave us a real ground truth for, did this patient have this disease? Did this patient have this pathology? And provide us a real ground truth to measure ourselves against. What it also meant is that we had a ground truth to measure the ophthalmologist against. And so that enabled us to test our algorithm versus expert ophthalmologists on a real-world data set that was a good representation of our use case. And going through all of these fine-grained details is a really critical aspect of ensuring that the algorithm is safe for the use case that you are determining. Now, I would right now be showing you some results, and essentially I can sort of skip through most of them. The sort of summary is we were able to show that the algorithm could perform at the same level on this specific use case as an ophthalmologist with 20 plus years experience. And referring back to Amar's sort of conversation around, like, is AI going to replace it? The key, replace people from their roles. The key is that this algorithm took us a long time to train to replace one task of 1,000 tasks that an ophthalmologist needs to undertake at a hospital. And the rigor that we needed to go through to prove that the algorithm was suitable for that task was quite complicated. But there is obviously a huge amount of opportunity here. But the key for us was always demonstrating that the algorithm could solve the right problem, but was evaluated in the right way. But this was still against a retrospective data set. So we're excited to be moving forward into a prospective analysis of the algorithm in real-time care and ensuring that the safe use of that algorithm in a prospective trial still returns the same results, because we're still working on some retrospective data set. And so I hope that that's given you some indication, without some of the technical detail, on why I believe there's a need for more product managers with research backgrounds thinking about research concepts and how does that research translate. Because the more product management and the more people thinking about the real-world application are working in research, the faster we can translate the opportunity of AI into the impact of AI. So thank you very much for your time. I'll leave it there.